이번에는 프라운호퍼 연구소에 연구진들이 직접 답변하는 Q&A 세션을 진행하겠습니다. 사전 접수된 질문 중 가장 많이 나온 질문을 중심으로 연구진 분들의 전문적인 답변을 들어보겠습니다.
So I briefly first about the eco-friendly solution for the packaging. As you know, the film applied with our gas barrier product Pexsphere is considered a monomaterial. And in Korea also, we are very interested in the recycling of the packaging, and some of the audience also are very interested in that theme. So we'd like to know a little more about the monomaterial. So are there regulatory guidelines in Europe for monomaterial? Is there a specific material composition percentage required for film substrate to be considered a monomaterial?
I think the question is for my presentation. Monomaterial means if the material has at least 90% of one specific type of material and 10% none of that material. So, for example, it can be a polyolefin-based monomaterial, then 90% should be polyolefin and 10% can be adhesives, inks, and so on. And yes, there are guidelines for monomaterial specifications in Europe, especially now that this packaging and packaging waste regulation became active since last week. These recyclability guidelines are going to be more and more used, and they will be returned also to regulations. For the time being, we would recommend you to check CEFLEX guidelines, so Circular Economy for Flexible Packaging, CEFLEX, and also Recyclas. So these two are the guidelines that the European converters, packaging producers, and especially material producers who came together and prepared these guidelines to be used for the regulations. So these would be our recommendations. Okay. So 90% simple material, 10% foreign, and check the CEFLEX and Recyclas guidelines.
Thank you.
No problem.
So much. And the second question is about heat sealing properties. So what are the heat sealing properties of BioPEX PLA and PLBH based coating solution? How resistant are they to moisture?
Okay, yes, in the project BioPEX we develop these formulations based on PLA, and from the PHA group, the PHBH we worked. And depending on this formulation is then the solid content in the formulation and then the coating weight on the paper. And so and this thickness influenced then also the sealing behavior. But also in our case we applied around 5 to 10 gram per square meter, and these layers were sealable. It was possible to produce small pouches for chocolate bar. We carried out here in shelf life tests. And so we receive really good sealing quality of this also thin layers. But this can be an optimization step then in a follow-up project. And regarding the water resistance, yes, these materials have a good water resistance, also known from other packaging solutions by extruded films, and better than bio-based materials. Yes.
And paper packaging. So we not only monomaterial but also paper packaging is well developed nowadays in Europe and also in Korea. For paper packaging, are inorganic deposition solutions like Alox and Cyox the most effective option for achieving moisture barrier properties? Or is there any other options for that?
This question is probably to me, to my presentation. The very short answer to this question would be yes. But there is the general metallization missing, where we only apply aluminum on the paper. The important thing is, when we talk about inorganic coatings on paper, to prepare the paper well enough for it to be PVD coated, that means we need to have a planarization layer where we can apply these inorganic layers. But if you can do so properly, then it is the best barrier against moisture you can have. I also introduced one process to create these inorganic layers by a transfer metallization. This would neglect those general negative properties of paper, roughness and hygroexpansion, meaning we build up the PVD layer on a polymeric film and then adhere or laminate the polymeric film with the PVD layer against paper, and in the last process step we remove the polymeric film, making it a release layer, and then we end up with a solution where we have an inorganic layer made of metallization, Ciox or Alox on the paper without ever having the paper in the vacuum or in the PVD process.
Move on to explore hybrid coatings. The first question from the audience is, what would be the most critical factor for an Omosair to achieve both oil resistance and water resistance?
Very good question. I think that it's not only for Omosair, it's for general finding the alternatives for PFAS, because the CF bonding is very special. You have a special polarity and there's no alternative, no other bonding that imitates this special structure. So you have to imitate, for example, this behavior, this long chain of the material. And this can be done by, for example, wax materials, so also long alkyl chain in Omosair. So that is the one aspect of your question. The other is there's the oil resistance. That is not so difficult to achieve, but it's more difficult to have this oil repellency. So really to form a droplet of oil. And this behavior is completely different from forming a droplet of water. So in principle you have to have two different materials, the one more for the oil, the other more for the water. And to combine this in one surface is not easy to develop and not easy to find. Then another aspect is water resistant is the one property, the other is really again the repellency towards water. The Omosair, for example, is very resistant towards water. Without any modification, it's not repellent, but it can achieve high contact values around 170 degrees towards water. And so water repellency is not an issue, but the combination together with oil repellency.
And the second question, it has been observed that Omosair can improve the wet strength of paper materials, and when combined with conventional starch, it's enhanced the wet strength, seem to contribute to the increased strength. Would this interpretation be accurate?
Yes. When we planned this project, we thought about the basic properties of Omosair, and what Omosair can very good is to form chemical bondings to inorganic and to organic structures. So you have reactive groups in the Omosair, and then they can react with different other functional groups. And in this project and with these products, we use this possibility to have a lot of different connection points to other interfaces. And so the Omosair is an additive and bonds the different starch molecules together, and this increases the wet strength of the material.
All of you, this has been an insightful discussion, and I truly once again appreciate the expertise and perspective shared today. And thank you all for Fraunhofer, IVV, and ISC, and also to the audience, your time and engagement. Thank you.
Thank you.